In Lora learning module, we will learn about the basic setup for Lorawan with online integration and computing protocol. This content of this module we will go through in the next slide. This domain is under Wireless Network and Analytics by University Putra Malaysia. This module we organize into 9 subsections as follow. First, we will start with introduction. We will explore the fundamental framework of Lorawan network and get to know setup required for Lorawan network. Example of Lora node device also will be covered in this subsection. Second, to make Lora work, we need synchronization between software and hardware. In this subsection, we will look on 2 types of gateway, which is indoor and outdoor. Then, we will identify software or compiler required for Lora node device. Third, the driver to be installed for Lora node device. This is to make sure the computer able to find the Lora node, so we can write the code and compile it in the specific software or compiler. Fourth, due to the region requirement, Lora operating frequency will be different from one country to another. Therefore, please consult your local regulator for specific frequency. For example, in Malaysia, Malaysian Communication and Multimedia Commission, or known as MCMC, is responsible in spectrum allocation. Therefore, in this section, we will explain on setup for Lora frequency. Fifth, Lora offers good security protocol which allow only authentic communication between Lora node and gateway. Hence, this section we will explain on joining Lorawan server using EUID and OTAA keys. Six, data sent and received from Lora node to gateway is in format of hexadecimal. Therefore, we could convert into string by using JavaScript inside a Lora server. This section we will go through on how to do packet conversion to string using Java. 7. To write and store data into the cloud, we need to configure the Pipedream. We will link it with a Google Sheet to store the data. Number 8, followed by the link a database to Lorawan server for a seamless data storing. And finally, we will test and validate our Lorawan network. This slide to illustrate the overall connection of our Lorawan test setup. To operate Lorawan network, you need Lorawan server to manage your gateway and allow the devices to securely communicate with the cloud. It is the heart of every Lorawan network. The main network server responsibility is assuring the security, data routing, and battery optimization of Lorawan gateway. The Lora devices can be any kind of sensor which carry the essential in situ data to the gateway. The data received by the gateway pushed into the cloud storage via LTE network. The deployment scenario can be in various ways. For example, often people use cloud-based launcher. This option runs the services in registered cloud by launching the stack from the Google Cloud, for example, using a Google Sheet. Finally, the meaningful information will be presented via dashboard, for example, using Grafana. Now we will continue our module by describing an example of Lora system. For example, Lora solution can be deployed for various applications, for example, in air monitoring, utility services, for example, like water billing, LPG gas, and many more. And it also can be deployed for agriculture, forest management, and many more applications. For example, in this slide, we will describe the Lora air pollution device. There is 5 stages or 5 process involved. First, to capture air-related data using a specific sensor. In this example, we use 4 different sensors. First, we have temperature and humidity. Second, we have ozone sensor. Third, we have carbon monoxide sensor. And finally, we have dust sensor. These all 4 sensors are essential in order to read the ambient temperature. Then we have LCD, purposely to display the data read by those sensors. And the intensity of the LCD can be adjusted using a tunable resistor. As this system will mainly deploy for outdoor use, so we have to regulate the temperature using the exhaust fan. So we connect to the system, and at some threshold, for example, when inside the system the temperature exceeding 40 degrees Celsius, the fan will be switched on. And to conserve the battery, it will be switched off again once it reach the threshold temperature, for example below 25 degrees Celsius, for example at night. Next, step 2, the data captured earlier will be forwarded to the gateway and ready to be pushed into the cloud server. In our setup, we use LTE network to push data from the gateway to the cloud storage. Step 3, the Lora server is responsible in managing gateway for secure communication with the cloud. Next, step 4, the store data in Cloud Marketplace Launcher. In this example, we use a free Google Cloud, and we store and we write the reading from the sensor using Google Sheet. This is not limited for the Google Cloud. For example, you also can use the Amazon Cloud Solution and others cloud solution provided. In step 5, Lora offered flexibility in displaying the data. For example, you have several options of dashboard, but the most common used by the people or by the researcher, they're using Grafana since it is free.
The next part, we're going to have a session on the hardware, software, and software requirement in installation. So for this part, we're going to have some overview on the gateway requirement. So what type of gateway available, then how the installation works being done, because we have to make sure that the gateway placement is in the right way of doing that. Then apart from that, we're going to explore a few hardware platform available, and then how we're going to choose which type of platform that is that can be used for the deployment of a monitoring system. And the last one will be on the hardware and software requirement, which is a type of programmer available and how to deal with that. Okay, for typical installation, as we can see from the previous diagram, so we need a gateway. So these are the hardware or the gateway available. So there are 2 types of gateway. The first one is outdoor, and the second one is indoor. So there are a lot of platform available. Example, for our project, we use a curling type of platform. So you can explore other kind of LoRa gateway. Example, it is Libelium or Winex, then etc. But the most important things for the selection of gateway, you have to know that how your gateway performs in terms of frequency. So make sure you are using the right frequency, and also what are your intention of your deployment. For example, if you have an indoor application which within a very limited area of sensor placement, maybe around 10 to 20 meters, so you just need a indoor gateway. So indoor gateway compared to the outdoor gateway is much cheaper and have a very limited coverage. But if you are looking for the very wide or large area of deployment, example here, the first picture shown the outdoor gateway. So this outdoor gateway can cover surrounding UPM. So we place the outdoor gateway on top of our rooftop. So this gateway can covers up to 10 kilometers coverage area with line of sight. But of course, if you have a blockage due to some attenuation of trees or buildings, then the coverage will be limit maybe around 1 or 2 kilometers. We can do some measurement, or what we call a drive test or RF measurement, to ensure that the coverage is within the area that we want. So another things that you need to consider for the selection of gateway, you have to select the appropriate antenna gain. So you need to check with your regulation. Example, in Malaysia, we have Malaysian Communication and Multimedia Commission. So they do some regulation on what kind of EIRP, or maximum effective isotropic radiated power, that permissible for the LoRa deployment. For example, if I'm not mistaken, in Malaysia, the maximum ERP is around, I think around 10 dBm something. You need to check for at your country. So another thing for the outdoor, you have to make sure that you have appropriate or good grounding or surge protector, because this is to prevent the module from the lightning, because the outdoor gateway is very expensive. So you need to make sure you have a proper closure, typically minimum protection from the rain, and you have to make sure proper grounding. So you can have a copper grounding or some lightning arrestor installed for the outdoor gateway. While for the indoor gateway, you need, because it is indoor, so you need to have proper ventilation. So example, aircons, or you can have a fans before the underneath the gateway to make sure the gateway is working on the right temperature. Another things what we need to have for the gateway, we need to have external connection to the internet. So this can be done either using, example, for the indoor gateway, we have a LAN connection, and for the outdoor gateway, we have a SIM card for the LTE connection. So that's what about the outdoor gateway and indoor gateway that you can consider for your deployment. The next step is, once you have you identify the gateway that you want to use, you need to identify what kind of platform that you're going to have. For example, as I mentioned before, there's a lot of LoRa platform available. Example, this is by STM company. So this module is very special. So you can use for LoRa and Sigfox. So you can have both either one. So the same board or the same chipset you can program to function as a Lora or a Sigfox. You can also use other kind of platform, example Winex or Libelium, but make sure you have the same standard protocol. So there are lots of Lorawan version 1, version 2, etc. So make sure you have the right version and the right frequency to make sure you can connect your sensor, your Lora module to the gateway. These are the link of the STM discovery. Just to have some overview, what are the good thing about this? We choose this because there's a lot of the first one, it can cover both Lora and Sigfox. So for our research and education, so we can have some project working on Sigfox, some project working on the Lora. So and another part, it works on ARM 32-bit Cortex CPU, and it has 192 kilobyte of flash memory. So this is very important. So it depends really on your application, how massive the data you are dealing with, how many sensors that you want to integrate. So you have to select the right performance in terms of CPU processing and enough amount of flash memory. Then for integration of to the sensor, there are two parts that you need to identify before selection of platform. So the first part, you need to identify how many ADC and the second one, how many DAC channel available. So example here for this board, for BL072Z Lorawan Discovery Kit, it can support 12-bit ADC with 13 channels. So basically you can have 13 type of analog channels, analog sensor to be integrated. Then you have 12-bit DAC channel. So this is very important because based on our experience, we would like to share. It is advisable to use digital sensor because in terms of reading, it much more accurate than it prone to noise, which is when you are dealing with monitoring of sensor or deployment of sensor at the field. So you have a lot of noise, not only by the board itself but by the environment and etc. Then once you have identified the hardware required, so you need to have a software platform. And for this kind of for this board, there are two software or programmer that you can use. So the first part, which is come with the STM32 ST-Link utility. So for this part, you can use STM32 Cube Programmer. So this programmer, it allow option of programming and upload content verification and programming automation to scripting. Then the second one, which is much more user friendly, is Arduino based. So
now we will continue on next subsection for board setup. In this section, we will go through the process to install the Arduino driver. The Lora STM32 board support both STM ST-Link utility compiler and Arduino IDE compiler. In this example, we choose Arduino IDE compiler because it is free and compatible with STM32 board. It also can be available for both Windows and Mac operating system. First, you have to install Arduino IDE compiler. Then you need to open the Arduino IDE compiler, go to the File tab, then Preference tab, and select a setting. Look for the additional board manager URL, copy and paste link as shown in the slide. This additional URL will allow Arduino IDE to find the Lora STM32 board upon updating board information. Then you have to install and wait until the download is completed. Upon completion, Arduino IDE will do driver installation for you. Of course, to start configure the board, you need to plug in the USB cable into available USB port on your computer and wait until the power LED blinking and turn to solid. In case the power LED keep blinking, try unplug and plug in again. To confirm your Lora STM32 driver successfully installed, go to the tab and select the Clara Corp STM302L board. Next, now we will go to the programming to the board. In this section, we will set a frequency for the Lora. So before we continue, you need to select your Lora STM32 from the Arduino IDE compiler. In our case, we select board as shown in the slide. Now, we will continue setup for the Lora frequency. Here we use an example of Lorawan join OTAA. Before that, you need to confirm with your local regulator which frequency is available in your country. When you open the script, look for the Lorawan.begins and replace the frequency according to your country. Now, the process for the setup frequency for the Lora is completed.
Next, we're going to do the joining of Lora node to Lorawan server. So we need to register the device to the server in order to make sure both Lora nodes can communicate and send the data to the server. So there are few types or few ways for the connection of Lora nodes to the server. One of it, what we call ABP protocol. So ABP is the meaning is activation by personalization, and the second way, what we call as a OTAA or over the air activation. Or sometimes different, it can call over the air authentication. So what are the main difference between ABP and OTAA? When you do the deployment of LoRaWAN networks, you need to decide from the beginning how complex the networks you're going to have, and how many sensors, and what are the protocol for the joining protocol to be used. So for ABP, using a fixed device address and session keys. So meaning that with this kind of setup, the Lora node or end device skips the join procedure and make it the network much more simpler. It's like having a fixed MAC address without any changing. While for the second part, which is OTAA, the end device is provisioned by the root keys. So meaning that the OTA keys is a dynamic, the device address is dynamic. So it need to assign to an device and the root keys are utilized to derive the session keys. So these are the main difference. So there might be a question, which is better, OTA or ABP? There are a few drawbacks of ABP. The first one is the ABP end device using a fixed device address. The second one is ABP end device use a fixed security session. So this is another drawback. Unlike ABP, OTA end device renegotiate frame counter for each session keys. And the third one, ABP end device use a fixed network parameters. For example, the RX1 delay, RX1 data offset, data rate index, frequency, and etc. So these are the main difference between ABP and OTA requirements. In our case, we are using a OTA type of connections. So in OTA type of connection, there are a few parameters that we need to grab and set in the system. So the first one, what we call as a EUID or device ID, and the second one is a OTA keys. So how to get the device ID? EUID is like a MAC address of the Lorawan nodes. So when we do the connection from the nodes or from the Lorawan device to the computer, and we run the serial listener program, so we can see from the listener the device UID. Example, in this case is equal to 343531315E377511. So this is very unique to that particular device only. So if you have 2 or 3 devices, you need to get each of the device ID one by one. Then we need to register this device ID in the server. So that will be the first step. The second step, you need to register the device ID in the server. For our test setup, we have a ChirpStack based Lorawan server, which is an open source server. The indoor and outdoor gateway pointing to this particular server. So here you can see there are a few modules in the server. Example, this is to configure the number of user, the service profile, device profiles, and the gateway. If you have more than one gateway, you can do the configuration over here. Then the application. This is the most important part when we want to register our device. So example, you have 2 or 3 device. So the first one, you can have a air quality device. The second one just a test, and the third one is a Lora application. So from here, what we need is we just create one test node. Example, then we give the device description as a training nodes. Then we copy the device EUID from the serial port listener and put inside here. And we have to make sure that the device ID is the same in the server, or else it cannot be registered. The next step is to generate a app key or application key. So this is very important because the nodes need to have the same application key sending and the same application key at the server, or else the connection cannot be established. So we can generate the application key under this module. Example, application, then the air quality nodes, device, and air quality. So go to the key OTAA tab, generate the app key, and set the device key. So once we set the device key, it will stored in the server. Then we need to copy the application key and put in the Arduino program for the connection. For example, in this script, Lorawan join OTA script, so we define our device EUI ID and we define our app key. So these are the most important one. Then next, at the Lora server, we can monitor whether the connection is success or not. We just go to the application, Lorawan application, device, and the nodes that we have configured. We go to the live device data. So from here, we can see there's a uplink message coming from the nodes to the server, together with the message or the data that being sent. So the data really depends on your program, who could come from the sensor or just a blank message. So once you have this message, meaning that your first part of joining between the Lora nodes to the Lora server was success.
In this slide, we will show the example on how to do a packet conversion to string using a JavaScript. Although binary payload are perfect for Lorawan application, most web application programming interface, or known as API, cannot understand this payload. Hence, a payload decoder is required. In Lorawan network, decoder is a JavaScript that recognizes the payload as a byte array and return a decoded value object. First parameter, commonly named as a bytes, binary payload as a number series, with each number is a byte in decimal notation from 0 to 255, which is the same as in hexadecimal notation from 0x00 to 0xFF. Second, the second parameter, which is usually called port, normally from 1 to 23. In this example, there are two data types transmitted to the server and hence required two different JavaScript functions to decode it. The first data type is float value, which is from 9 out of 10 payload transmitted in each loop of this project, and it is mostly the sensor value. The second data type is string value, and it is only 1 out of 9 packets transmitted in each loop, and it is the main pollution name. To allow the decoder to differentiate between the float and string packets, the port number is used to identify the payload. Next, we will show the example on how to configure Pipedream. The data received on the server are not saved or processed, and it is only decoded. Hence, it is very important to forward this data to another application to be stored or displayed. The platform used on this application is a Pipedream. It is an integration platform for developers to create and operate workflows that combine application, data, and API with no server or infrastructure to maintain. The main use for this platform here is to receive the data from the server through HTTP integration and store it on Google Sheet. Another platform had to be implemented after receive the data to process the upcoming data is one raw since sensor values are transmitted in separate packets. After successfully sign up signing up on the platform, unique HTTP URL was generated. The URL was added at the endpoint on the server as shown in the slide. After adding the URL, the packet started to appear as event on Pipedream. Since all sensor data received on Pipedream as separated event, another step process has been implemented to process the upcoming data on one row to be stored after on Google Sheet. Pipedreams allow user to write a Node.js code to process in the events, and Pipedream also allow user to add a step to store data in Google Sheet. The step has been created and Google account was linked to the setup. After adding the URL, the packet started to appear as event on Pipedream, as mentioned earlier. Since all sensor data received on Pipedream as separate event, another step process has been implemented to process the upcoming data on one row to be stored on the Google Sheet. The step has been created and the Google account was linked to the step. The sheet ID was added along with the sheet number to identify which sheet the workflow will use to store the row. The example of the JavaScript code is shown in the slide.
We're going to link the database to the Lorawan server. So the idea is basically we want to store the data that come from the sensor. So there are two types of integration that can be done through the Lorawan server. The first one is using a local storage or InfluxDB. Then the second one using a HTTP push. So in HTTP push, we want to send the uplink data to an endpoint and receive on the downlink data over HTTP. The main advantage of HTTP push is it is very fast and it uses a push integration method. There are a few types of HTTP push application available, portal. Example, we already mentioned using a Pipedream, or you can explore other type of HTTP platform like RequestBin. So we already configured the HTTP push in Pipedream. So we copy the link of the Pipedream HTTP, then we insert the HTTP push link in the Lorawan server. So by doing this, is basically the Lorawan server will forward the message or the packet received from the sensor to the Pipedream server using HTTP protocol as shown in the slide. Then we come to the last part of the module, which is testing and validation. So during this stage, we want to make sure that the data from the sensor was successfully received and stored in the database. So these are the data view in Pipedream. Because we use a HTTP push, the message from the sensor will be forwarded by the server to the Pipedream, and every single line or single data of the message will be stored in the spreadsheet of the Google Sheet. So example, line 20, we have 100, 101, 102, then etc. So using this data, we can download the data and do some further processing. Example, we can use we can feed in the data to the machine learning platform like Python and do some trending and analysis. Or we can visualize the data using Grafana. So from the Grafana platform, we can link to the Google Sheet, then view the data in the Grafana platform. Next, you can find a few references which is might useful for you. With that, we end the session. Thank you very much.